In this video, we are going to learn UJT triggering of SCR. Now, triggering means turning any device on. We have already seen resistor triggering and resistor capacitor triggering of SCR. Now, UJT triggering has more advantages over resistor and resistor capacitor triggering. We are going to see, we have already seen in previous video resistor and resistor capacitor triggering. Now, UJT triggering is also called as synchronized triggering. Why it is called synchronized triggering, we are going to see further in this video. Let us first see working of this synchronized UJT triggering circuit. Initially, 4 diodes, by using 4 diodes we have made our bridge rectifier circuit, which is used to produce pulsating DC. So initially what happens when positive half cycle, here we can see this positive half cycle appears at the input of this rectifier, that is this point becomes L, this point becomes N. Then what happens, diode D1 and D2 gets forward biased, and at the output of this rectifier we get this type of pulse. By neglecting voltage drop across diode, entire supply voltage appears at the output of this rectifier. Similarly, in negative half cycle, what happens, diode D3 and D4 gets forward biased. In negative half cycle means at omega t is equal to pi, when supply voltage gets phase reversal, that is this point becomes L and this point becomes neutral. Then diode D3 and D4 gets forward biased, and again at the output of this rectifier we get this type of DC, pulsating DC signal. So this type of pulsating DC signal can also use directly to charge this SCR, but it may vary charging and discharging type of SCR, as if there is fluctuation in this our input supply voltage, if this waveform is not symmetrical, that is positive half cycle and negative half cycles are not of same duration, then this charging and discharging time of capacitor is also varied. So we have used here Zener diode. Now Zener diode is act as a voltage regulator. When operates in reverse bias, Zener diode act as a voltage regulator. So at the output of this rectifier we have connected this Zener diode, which is in reversed bias, which produced constant output voltage Vz, constant output voltage in spite of there is fluctuation in supply voltage. Even if there is fluctuation in supply voltage at the output of this Zener diode, that is at this point we get constant output voltage Vz. Now this constant output voltage is used to charge this capacitor Vc. Now this capacitor charges through this resistor R, variable resistor R. This variable resistor R decides charging time of capacitor. Here we can see when this constant voltage Vz is applied at the input of capacitor, this capacitor starts charging through this variable resistor R. Now this charging time is decided by value of resistor and capacitor, which is also called as RC time constant. So if resistor is kept at low value, capacitor charge rapidly. So here we can see, now when the charge, this capacitor acquires sufficient charge to trigger this UJT. Now how UJT works and how UJT triggers we have already seen in working of our UJT. There is one video which I have made on working of UJT. Now in that video we have already seen working of UJT, which is when this input voltage VE becomes equal to eta VBB plus VD, then this UJT turns on. That is when this capacitor acquires sufficient voltage to trigger this UJT, then this junction, this PN junction which is in UJT, it breaks down and this UJT turns on. And now capacitor starts discharging through the emitter and this base of UJT. Here we can see initially capacitor starts charging when capacitor acquires sufficient charge, which is nothing but eta VBB plus VD. Then what happens? This UJT PN junction of this UJT breaks down and capacitor starts discharging through this emitter and base of this UJT, and we get this type of pulse, initially charging and discharging. So this type of pulse at the base of this UJT we get. And if we connect this transformer, if we connect primary winding of this transformer at the base of this UJT, which results in current through this primary, discharge current of this capacitor through this primary. When the discharge current flows through this primary, same discharge current replicate at the secondary side also, secondary side of transformer. If we use multiple pulse transformers, we can get multiple gate triggering pulses, which we can apply at the gate of SCR. When capacitor acquires sufficient charge to trigger this UJT, that charge is equal to nothing but, that charge is also called as peak point, peak voltage Vp, which is equal to eta VBB plus VD. Now what is this eta VBB plus VD? You can see in working of UJT video which I have made on working of UJT. You can see in that video. When this capacitor acquires charge eta VBB plus VD, this UJT breaks down and discharge current flows from this emitter to base of transformer. When this discharge current flows through, at the base we have connected our primary winding of transformer, pulse transformer. This transformer is nothing but pulse transformer, which is less bulky. So one more advantage of UJT triggering is we can use pulse transformer, which is less bulky. When this discharge current flows to primary of this pulse transformer, similarly that current replicate on the secondary side, and at the secondary side if we can get triggering pulses to the SCR. So this way this UJT triggering circuit works. Now why it is called synchronized UJT triggering? That is, at the each duration between the two pulses is equal, or there is no variation between two triggering pulses. These pulses are equally synchronized with our supply voltage. When supply voltage is if there is variation in supply voltage, at the output of the Zener diode we get constant voltage. So due to this constant voltage, even if there is variation in supply, then also we get triggering pulses at the regular interval at the output of our pulse transformer. So this way our UJT triggering circuit works.